In this video, we will be solving the question paper of internal test 2, which was based on MCQs. So let's get started. The first question is, which of the following interpolation techniques is used to find the values of a function at points lying outside the known data points? So for finding the value of function outside the known data points, we will be using Newton's divided difference interpolation. So the correct answer will be Newton divided difference interpolation technique. The next question is, which of the following is not a disadvantage of Newton forward interpolation? So Newton forward interpolation is not computationally intensive. So it is not the disadvantage. All the others are disadvantages as we cannot use it for large values of n. It requires equally spaced data points. It is sensitive to errors in the data points. So the correct option is D. Next question is, which of the following interpolation techniques is used to find the values of function at points lying before the known data points? So the options are Newton forward interpolation technique, Newton backward interpolation technique, Newton divided difference interpolation, and Lagrange's interpolation. So we will, if the point is lying at the end of the data values, then we will be using backward interpolation. So we have to find the values of a point lying before the known data points. That is, the point is lying at the end. So we will be using Newton backward interpolation technique. The next question is, which of the following interpolation technique uses a polynomial of degree n minus 1 to interpolate n data points? So the correct answer for this will be Lagrange's interpolation. Moving on to the next question, which is, which of the following is not a disadvantage of Newton backward interpolation technique? So Newton backward interpolation cannot be used for large values of n. This is not a disadvantage of backward interpolation. We cannot consider it as disadvantage. So next question is, which of the following interpolation technique is used to find the values of a function at points lying between the known data points? So when we from before only we know the point and the data points around it, then we will be using Lagrange's interpolation. Forward in interpolation is used when the point is lying before, and Newton backward is used when the point is lying after, and Newton divided difference is used when the point is not lying in the given data points, it is lying outside that. So we will be using Lagrange's interpolation. Next question is, which of the following is correct formula for Newton divided difference interpolation technique? So the correct formula is option A. Next question, which of the following is the correct formula for the first divided difference in Newton divided difference interpolation? So the correct formula for Newton divided difference operator is what the first order formula is. So the correct answer for this question will be option states that what is the basic difference between Newton forward and backward interpolation? We know that Newton forward interpolation uses forward differences, that is forward difference operator, whereas in backward interpolation we will be using backward difference operator, that is backward differences. So option A is the correct answer. Next one is, in Newton's divided difference formula, what is the purpose of using higher order differences? Why we will be using higher order differences in Newton divided difference formula? So it increases the accuracy of the interpolation. So using higher order differences increases the accuracy of the interpolation technique. So option A is correct. Next question, which of the following interpolation method is based on a polynomial approximation? So Newton forward interpolation is based on forward differences. Newton backward is based on backward differences. Lagrange's is based, all of them are based on the differences, which are the polynomial approximations, and the divided difference not based on polynomial approximation. So the correct answer will be D. Next question. What is the difference between Newton's divided difference interpolation and Lagrange's interpolation? So in Newton's divided difference interpolation technique uses divided differences, whereas in Lagrange's interpolation uses polynomial interpolation. So the correct answer for question number 12 will be C. Question number 13 is, which of the following interpolation method is more suitable for unevenly spaced data points? So you already know that Newton forward and backward interpolation technique are, we cannot use them for unevenly spaced data points. So the correct answer will be Lagrange's interpolation technique. Next one is, which of the following interpolation method is known as method of finite differences? So the divided difference interpolation technique is called the method of finite differences. Question number 15 is, what is the order of polynomial used in Newton's forward interpolation? So its order is n minus 1. We can find the order from the formula itself of Newton forward interpolation technique. Question number 16 is, which of the following interpolation method uses the concept of interpolation error? So it's the Lagrange's interpolation which uses the method of concept of interpolation error. Next question, which is, which of the following interpolation method can be used to interpolate functions with complex values? So the best interpolation method is Lagrange's interpolation technique. So again, the correct answer for the question number 17 will be D, that is Lagrange's interpolation. Question number 18 is, what is the drawback of using higher order differences in Newton's divided difference interpolation? We already know that it increases the accuracy, but the disadvantage is higher computational complexity increases. So computational complexity increases, which will may affect the time taken to calculate the results. Question number 19 is, what is the main difference between Newton-Cotes formula and Gaussian quadrature formula for numerical integration? So Newton-Cotes formula uses equidistant points, whereas Gaussian quadrature formula uses non-equidistant points. Which of the following is an example of Newton-Cotes formula for numerical integration? So both of the Simpson's rules are generally the example of Newton-Cotes formula. So that's all. Thank you.